If we're really going to get you ready for a test, well, I want you to know what I know, so here we go. I'm going to read the instructions to you. Hopefully they make sense. So many of these derivatives are difficult. You have to use multiple derivative rules, look for the structure of the given equation, stop and check often, I suppose if you're doing it on your own. Even when you think you're correct, this should give you a pretty idea of derivative rules you know well and which you need to start memorizing. So when you do this on your own, or if you are looking up this video to try to get some help, maybe that is the derivative rule you need to know. So find the derivative with respect to x for each equation. Let's make sure they're all x. So all of these do have an input of x. So what I'm looking for is, oh, that last one's going to be hilarious, is if there was any implicit differentiation. And it doesn't say find dy dx or something, so we can use whatever notation we want. Y equals the natural log of 5x to the fourth is a chain rule situation. You know that 5x to the fourth is inside the natural log. So the derivative of natural log is 1 over the input. That input is 5x to the fourth, which has a rate of change of 20x. You know, I'm not going to write it that way, which has a rate of change of 5 times 4x cubed. And if you think ahead here, why would I do that? So I just don't have to do quite as much thinking. X to the third over x to the fourth means I have an extra x in the denominator, and 5 over 5 divides out. We're simply left with a 4 in the numerator. The derivative of e to the power of negative 4x, that's another chain rule. The derivative of e to a power is e to that same power, natural log of e. That power is negative 4x, so we're going to chain rule, multiply by negative 4. Don't forget your parentheses. And dy dx is negative 4 e to the negative 4x. Always be prepared for multiple choice, so we want to simplify as much as possible. If you know the derivative of e to the power is e to the power natural log of e, then you know the derivative of 7 to a power is 7 to the power natural log of the base 7. And then we can do, okay, that exponent is 3x squared plus 4x, which has a rate of change of 6x plus 4. I don't think I really need to rewrite that because we can't really combine anything, so I think I'll leave it there. Maybe we want to move the 6x plus 4 out front. The derivative of sine times cosine. Whenever I see sine, cosine, tangent, whatever, I wonder if I can combine. And I really can't, or at least not easily. I suppose I could think of this as 2 sine cosine over 2. Because that would be sine of 2x, but whatever. Okay, so the derivative of a product of two functions is the first function, sine, times the derivative of cosine, which is negative sine, plus the second function, cosine, times the derivative of the first function, and what is that? Derivative of sine of x is cosine of x. So f prime of x is cosine squared x minus sine squared x. That should feel like a trigonometric identity, and that is cosine of 2x, or cosine of x plus x. So if you didn't see that coming, you might miss that on a multiple choice because you don't know your trigonometric identities. You can check that out. Remember, cosine of x plus x is cosine of the first, cosine of the second, minus sine of the first, sine of the second, if you need it. Okay. So back to the derivative stuff. The derivative, and again, this is a similar structure of 3 to a power is 3 to that power, natural log of 3. And that power is 5x, so chain rule times 5. Now in this case, I think I will rewrite just in case it comes up. So, you know, you can think of this 5 as a coefficient in front of natural log of 3. So it might be the case that you get natural log of 3 to the 5th multiplied by that 3 to the power 5x. Be prepared for rearranging using trigonometry, algebra, logarithms, all that sort of stuff. Oh, I don't want to do this. Well, no real good choices here. Definitely two functions multiplied together, so I need to do the product rule. I could expand that first factor to the fourth power. That seems awful. So I'm just going to do the product rule. Okay, so the first function times the derivative of the second function, 5 stuff to the fourth. And that stuff is cotangent x minus 2x, don't forget parentheses, which has a rate of change. Derivative of cotangent is negative cosecant squared, and derivative of negative 2x is negative 2. And then what are we going to do? We are going to add the second function, cotangent of x minus 2x all to the fifth, times the derivative of the first, which is going to be 4 versions of x cubed plus 3 cubed, chain rule times a 3x squared. All right. So what are we going to do? We're going to factor some stuff out. So we can factor out definitely an x cubed plus 3 to some power and a cotangent of x minus 2x to a power. So we just take the lesser power, so that's a fourth power on the x cubed plus 3 and a third power on the cotangent x minus 2x. And so what are we left with here? X cubed plus 3 cubed. Right? Fourth. Oh, I got those backwards. I see. X cubed plus 3 cubed and cotangent stuff to the fourth. So out of the first one, I'd be left with that 5. 1 extra x cubed plus 3. And that negative cosecant squared x minus 2. And out of that second batch, definitely 3x squared. 1 extra cotangent. Oh, I lost the 4, so we'll make that a 12x squared. And just cotangent of x minus 2x. Pretty confident there, but man, that's ugly. Okay. Well, I said they were going to be hard. And then an easy one. Pretty straightforward. Derivative of sine is cosine. And we just have to do a chain rule 3 on that input 3x minus 4. Ooh, W. Okay, so what's the structure here? Well, maybe we want to rewrite that a little bit to make sure. So definitely the innermost thing is 1 plus x. That's inside a natural log. That natural log is inside of a tangent, and that whole thing is being squared. So we're dealing with that exponent 2 first. Okay, so 2 times our tangent to the first power, and tangent has a derivative of secant squared stuff, and that stuff is natural log of something else, which goes in both here. And natural log has the derivative of 1 over that stuff. And what goes in there? 1 plus x, 1 plus x, 1 plus x. And the derivative of 1 plus x is just 1. So I think I do need to slightly rewrite that, but you should know tangent and secant both have cosines in the denominator. So really, we can't combine much. So 2 tangent of natural log of 1 plus x, secant squared of natural log of 1 plus x, all over 1 plus x. All right. Another nested chain rule. Hopefully you can see that natural log has the input of secant, and secant has the input of the square root. Hopefully you've memorized that derivative of the square root. So the derivative of natural log is going to be 1 over the input. That input is secant, which has a rate of change of secant stuff, tangent stuff. And that input is the square root of x. which has a rate of change of 1 over 2 square root x. Why are you flashing? I don't know. Okay. So h prime of x is... Oh, that's cool. The secants divide, and it looks like I'm just left with tangent of the square root of x over 2 square root x. Right? 1 over secant tangent. Yeah, that seems good. Ooh, arc cosine. Now, I happen to remember the derivative of inverse cosine. If you don't forget the best way to do this is probably kind of the long way. So it's, your call if you want to do that. I'm not going to, because I happen to know that rule, and I assume most of you think you'll know that rule. Hopefully you do. Okay, so derivative of inverse cosine is -1 over the square root of 1 minus the input squared. Normally it's 1 minus x squared in there. And that input is 5x cubed plus 4x, which has a rate of change of 15x squared plus 4. Yeah, we need to multiply out that denominator. I'm going to make this thinner, just so I can write a little bit smaller. Okay, so y prime is, we'll put that negative out front, 15x squared plus 4, square root, maybe I don't need to square that out, because even if I did, there's no constant in the 5x cubed plus 4x all squared that needs to combine, but oh well. Okay, so 1 minus, and everything in here is going to be negative, so that's 25x to the 6th, and then it's going to be minus 5 times 4 doubled is 40x to the 4th, and then 4x times 4x is 16x squared. I don't know which one of those is better, but they're both options. Alright, the derivative of cosine of natural log of 3x. These are difficult. You're right. You're right, meaning the past version of me who wrote these. Okay, but really, I'm hoping that you get the structure. I wonder, are there more product and quotient rules here? Oh, there's an ugly one. So I guess we're assuming you have the product and quotient rule stuff down. So cosine of natural log of 3x, we're going to do the derivative of cosine first, negative sign. Still of natural log, which has a derivative of 1 over the input. That input is 3x, which has a rate of change of 3. So we can simplify a bit. So that's just going to be negative sign of natural log of 3x. The 3's divide, and just over x. There's no 2 columns, right? Okay, let's see. Can you see the structure without me rearranging? Hopefully you know the outermost thing is that cube. So we're going to have 3 stuff squared as our derivative. That stuff is tangent, which has a rate of change of secant squared of the same input. And that input is 4x to the 6th minus 2x. So that goes in both blanks, which has a rate of change of 24x to the 5th minus 2. I don't think I'm going to bother rearranging that. Wait, do we have to rearrange? What did I ask you to do? Stop and check often, multiple derivative rules. Oh, it does say simplify. Gosh darn it. Okay. But rearranging and simplifying, who knows? Let's see. So I definitely can't combine the tangent and the secant squared. And I guess if anything, what I would do is actually not multiply, but factor a 2 out of the back here. So that's going to be that 2 times the 3 in front is a 6. And then the most useful stuff, what would be left here? 12x to the 5th minus 1. which we could get a pretty easy 0 out of. And my tangent is squared, 4x to the 6th minus 2x. And secant is squared as well. 4x to the 6th minus 2x is the input there. Okay, that actually looks a ton cleaner. Oh, all right, cosecant, gross. Let's rewrite this with an exponent on that square, on the 6th root. So that's x to the 1/6, and let's put a dot in here so it's very clear we know we're doing product rule. Okay, so let's see. First function, cosecant, and we don't worry about the input right now because we're not doing the derivative of that cosecant, times the derivative of e to the negative 5x, which is going to be e to the same power, negative 5x, natural log of e, and chain rule times a negative 5. I think I'll write that negative 5 out front. Okay, so plus the second function, e to the negative 5x. I'm already thinking I'm going to have to factor those out in my simplification, times the derivative of cosecant, which is negative cosecant stuff, cotangent stuff. And that stuff is x to the 1/6. We'll rewrite that as the 6th root in a moment, which has a rate of change of 1/6 x to the negative 5/6. Okay, I'm just looking to see what anything in common between the two pieces. And it looks like what's in common is definitely that e to the negative 5x and a cosecant of the 6th root of x. Okay, so from the first term, what's left? Just a negative 5. Weird. And the second term, let's see, that's gone, that's gone. I'll erase these in a moment. So we're just going to have plus cotangent of the 6th root of x over 6 times the 6th root of x to the 5th. Okay, let me get rid of those underliney bits. Oh no! Cosecant, cotangent. Oh, I lost that. Okay, I think that's good. Oh, thank goodness, something easier. The derivative of natural log, this is a pretty straightforward one, is 1 over the input. That input is x squared plus 5x, which has a rate of change of 2x plus 5. I can just do that in the numerator. And, you know, you might want to rewrite that denominator, even though we're not going to get a cancellation, x times x plus 5 in the denominator. These are getting ridiculous. I guess I probably should have left more room for the algebra here. So, product rule here, chain rule there, implicit differentiation on the y cubed. So x, oh, and implicit differentiation on the cosine of y. Negative sine of y dy dx plus 2x cosine of y. That's my first chunk. The derivative of e to a power is e to that same power, tangent of x. Chain rule, secant squared x, the derivative of tangent, and let's see, 3y squared dy dx. Which side do we want to move stuff to? I think we want to move the dy dx's to the right. So that's going to be dy dx times 3y squared, and then we'd be adding x squared sine y. I can do that without writing it twice. I don't know about you. What would we be left with on the left? 2x cosine of y plus e to the tangent secant squared, which means dy dx is 2x cosine y plus e to the tangent x secant squared x all over 3y squared plus x squared sine y. Oh, you gotta be kidding me. Well, I knew I wasn't going to want to do this one. Okay, what do we deal with first? The first thing we deal with is the quotient rule. And that's going to be denominator times derivative of the numerator. Once we get to the numerator, that's going to be the product rule. And each of those pieces has a chain rule. I better start really far to the left. When we get to the derivative of the denominator, that's a chain rule, and I also know people are going to, there's a plus here, so you really need parentheses on that chain rule. All right, let's see how we do. Starting all the way over here. Okay, so denominator. Ooh, there's a lot of stuff here, so I'm going to hit save first. So my computer's slowing down. When there's a lot of writing, it does that. Okay, so denominator, I hopefully copied correctly, times the derivative of the numerator, and the derivative of the numerator is the first function times the derivative of the second function, negative sine of x cubed times 3x squared. First function times the derivative of the second plus the second function, cosine of x cubed times the derivative of the first. Derivative of e to a power is e to that power times the derivative of that power, 2x minus 4. And don't forget, I need to close my bracket. We are still in the middle of a quotient rule. So minus the numerator, minus 4x plus 8 times cosine of x cubed times the derivative of the denominator. And it's a natural log, so let me give myself a fraction here. So 1 over the input, inverse secant. Oh, inverse secant. You got to be kidding me. Okay, well, whatever. And the derivative of inverse secant is 1 over the absolute value of the input, square root of the input squared minus 1. Oh, shoot. Natural log. Inverse secant of that stuff plus x squared. So it means I have a plus 2x up here, right? Because I'm multiplying by the derivative of the input to natural log. Yeah. Okay, and the input to that inverse secant is 2x. So 2x, 2x, which has a rate of change of 2. And that 2 only goes on the inverse secant part, so I think I will just put that up here. First function times... Holy crap, we're still in the middle of a quotient rule, but I know how we finish. And that's all over the denominator squared. Yeah, I'm not simplifying that, and then I will finish the other part in another video.